Good afternoon. Good afternoon to everyone. Okay, we get started. Okay, can anyone summarize what we were learning in the previous class? Anjali has already typed geocenter, postgrade, retrograde, satellite height, angle of inclination, angle of elevation, satellite period. Harini is responding satellite height. Karthik is responding angle of inclination, angle of elevation. Yes. Okay, ascending orbit, descending orbit, Venkateshwar Rao is responded, elliptical orbit, circular orbit, angle of elevation. Yes, very good. Geocenter, angle of inclination, angle of elevation. Okay, ma. Thank you for your responses. So this is about the angle of inclination. So that is for the orbital plane. So the angle of inclination is for the orbital plane with respect to the equatorial plane or the polar poles. Okay, North Pole or South Pole. So, and this is about the ascending orbit and the descending orbit. Okay. And we were learning about the angle of elevation. So the angle of elevation is for the satellite. It's not for the orbital plane. So it is for the satellite. So what is the angle of elevation? So it is the angle formed between the two lines. That is, the first line is the line drawn from the Earth ground station, that is the Earth station, to the satellite, and the line drawn from the Earth station to the Earth's horizon. So that is going to be the angle of elevation. Okay, so with all these factors in mind, that is the satellite period, that is the satellite position in the orbit, and what happened, that is we have to consider the geocenter, as well as all other parameters, this angle of inclination and angle of elevation. With all these factors in mind, we will be launching the satellite. And how does this satellite stay in its orbit? So to summarize, we say that if the satellite is that is 23,500 miles per hour, so if it is going in that speed, what happened, the object will leave the Earth's gravity, so it will escape from the, what is that, Earth's atmosphere and the surroundings, and it will not be placed in the orbit. So that is the first case. And the second case, that is, if it is very slower, then it will fall back to the Earth at the lower heights. Okay, so this is the second scenario. And the actual scenario is, if the satellite is being launched at a speed of 17,000 miles per hour, it will go into the corresponding orbit by considering all the factors, that is the angle of inclination, angle of elevation, satellite period, satellite height. So having all these parameters in mind, we have to launch into the orbit and make the satellite to stay in its respective orbits. Okay, so that is about the satellite launching and making the satellite to stay in its orbit. So now let us move further by understanding what are the different satellite orbits available based on the range of the coverage as well as the height of the satellite from the Earth's surface. So it is classified as that the different types of satellite orbits are LEO, MEO, GEO, Molniya orbit, and high altitude platforms. So LEO is nothing but it is low Earth orbit satellites. So which is very, very closer to the Earth's surface. It's at lower height. Okay, some satellites which are launched in this orbit, that is the LEO orbits, will be visible to our naked eye itself. So to be more specific, the satellite, nano satellite, which was launched by our university, that is the Satyabama nano satellite, it is launched in, that is, it was launched to be placed in this LEO orbit. And at one point of time, we were able to physically view it in the morning. Okay, one particular duration, it will be visible to our that particular location at one particular point of time. So we were able to see that satellite as well as the position of the satellite with our naked eye itself. Okay, so that is about the LEO, that is the lower Earth orbit, which is very closer to the Earth. Next one is the medium Earth orbit. Okay, so that is nothing but that is little bit far away from the Earth's surface, above the Leo. So this is going, the blue circle is going to represent the Leo orbit, medium Earth orbits. Okay. So apart from that, we have Geo. Geo is geostationary or geosynchronous orbit. So the even though the geosynchronous and geostationary are going to be the same, the little bit quite difference is there. So only important point here it is geosynchronous and geostationary will be orbiting in a circular orbit, and it will be orbiting with the same speed as the Earth's rotation. So there's this green color circle that is going to be the geosynchronous or geostationary orbits. Geostationary is nothing but it is exactly at the equatorial height, equatorial region. Okay, so it will be in a perfect circle and it will be placed in an orbit of the surface above the equator. That is called to be geostationary orbit. Whereas geosynchronous, it would have slight angle of inclination, but still it will be rotating with the rotation of the speed of the Earth. So that is going to be geosynchronous. We will see in detail one by one. Next type of orbit is Molniya orbit. So this Molniya orbit is something elliptical orbit which is across the polar region. So these orbits are most frequently used by the Russian people, which are very the Russian. You see, Russia is very much closer to the North Pole, is it not? So that will be used by the Russian people, and specifically it was launched by Russian people. And this Molniya orbit will be in a perfect, what is that, elliptical orbit across the pole regions. Okay, and this high altitude platforms, they are also something similar to Molniya, that is also going to be in the, what is that, elliptical shape, and that is going to have this perigee and apogee function. So this is going to be the perigee, is it not? The shortest distance of the satellite in the elliptical orbit from the Earth's surface, and the farthest distance height is going to be the apogee. So this is going to be the high altitude Earth orbits. Okay, high altitude, that is called to be here, or you can call it as high altitude platforms. Okay, so normally when we wanted to go for the continuous monitoring of a particular region where the human people cannot reach, in that places, these high altitude platforms are used. Okay, so those satellites will be launched in that particular orbit. So what are the different types of satellite orbits? First one is LEO, low Earth orbit. Then MEO, that is MEO, that is the medium Earth orbit. Then GEO, that is the geosynchronous Earth orbit or geostationary Earth orbit. Then we had Molniya orbit, that is across the polar region. It is going to be a perfect elliptical shape, and we have the high altitude platforms. Okay, so we will see one by one in detail. So this picture already we have seen, that is the Molniya high elliptical orbit. It is going to be in an elliptical shape across the polar region, and this is going to be the, what is that, circular geostationary orbit. Okay, and this is about the polar orbit, and this is the Leo orbit, and this is the geostationary orbit. So this is another representation of the satellite orbits. Okay, next we will see another representation. Here it is again, it is going to be Leo, which is very closer to the Earth, and this is medium Earth orbit, and this is the geosynchronous orbit. Geosynchronous need not be in exactly at the Earth's what is the equator, above the Earth's equator. And the important point here in this geosynchronous or geostationary orbit is the satellites which are placed in the geostationary orbits will cover one third of Earth's curvature. Therefore, a maximum of 3 satellites will have a 100% coverage. Is it clear? So maximum of 3 geosynchronous satellites or the geostationary satellites will have a 100% of Earth's coverage. So suppose a person who wants to communicate to a person here, he can communicate through these 2 satellites. So there will be inter-satellite links, okay, between these 2 satellites, and you can get communicated. So in order to have a 100% full coverage, normally all your television channels which are who are using satellite communication for their telecasting purposes, they will be making use of this satellites which are placed in the geosynchronous or geostationary orbits. Okay, so that is about the geostationary and geosynchronous orbit. So next, now let us see in detail one by one what are the features of each and every orbit, and what are the advantages and disadvantages of each and every orbits. Okay, so first let us start with low Earth orbit satellites, that is the LEO. So this is another representation. The one which was shown in the previous slide, it is going to be just one orbit. So here you see many orbits are there. So LEO orbit. So this many satellites are, it's an example of pictorial representation of this many satellites are rotating, functioning across the Earth, above the Earth's surface in the LEO orbit. Okay, that is the low Earth orbit. So it is at very closer height. Okay, so what are the features of that? So this is another representation with respect to the Earth's inclination. So what is that Earth's inclination? Can anyone tell? Sir, enable chat box, sir. Yes, your chat box is enabled. Yes. So even though Earth is going to be normally we call that as a sphere, it is not a perfectly exact sphere, is it not? So it is flattened at the top, North Pole and South Pole, and bulged at the, what is that? Equator region, is it not? In the middle. So it is flattened at the North Pole and South Pole, as well as it is bulged at the across the equator. Also, it is not perfectly standing in its own axis. So when we talk about North Pole and South Pole, some kind of inclination is there. What is the angle of inclination of the Earth with respect to the axis of the Sun? Yeah, 23.5 degree. Gaurav Mishra has responded. So you might have studied in your basics of science, is it not? Geography. Yes, 23.5 degree angle of inclination is there. Okay, so when you talk about equator, so this is actually the equator, that is also tilted. So Suresh also has responded, Karthik also has responded. So what does this 23.5 degree affect? So what is that, how does it affect our calculations and day and night calculations here? Yes. Because of that, what do we get? What do we feel? You remember all these things or not? Because of this only, for every 4 years, we will be getting 365, 366 days. Do you remember that or not? 366 days. What is that called to be? In day and night calculation for one Earth's revolution. What is that? Leap year. Do you remember all these things? We'll be getting leap year. 1 day extra we'll be getting. Okay, every 4 years we'll be getting 1 day extra. 366 days. Okay, normally 365 days. Yes. You should all have all these things in mind. So the basics, whatever you have learned. Okay, so that is also going to affect. So you see, so this is the equator. So this LEO orbit is the orbit that is less than 1000 kilometer above the Earth's surface. So it will be orbiting here. Okay, it will be at the maximum, it will be orbiting in a circular orbit only. Okay, so it will be less than 1000 kilometer. You see, all the LEO orbits are all circular, at the maximum circular. Only very few will be placed in what is that? Not maximum, or many of the satellites will be placed in elliptical. Okay, so low Earth orbits will be placed in a circular orbit. So with the height of less than 1000 kilometer above the Earth's surface. So what are the other specific features of LEO satellites? LEO satellites are much closer to the Earth than the GEO satellites, ranging from 500 to 1500 kilometer above the Earth's surface. Okay, so this is the distance, at the maximum distance at which the LEO satellites are launched. Okay. Yes, Suresh has responded. The shape of the Earth is ellipsoid. So normally we don't call that as a sphere. Okay, little bit ellipsoid in nature. That is, It is flattened at the North Pole and South Pole, and it is bulged at the across the equator. That is called to be ellipsoid. Yes, very good. That is going to be the shape of the Earth. Thank you, Suresh. Okay, so it is the height of the satellite for the orbit which are placed in the low Earth orbits is going to be 500 to 1500. So these LEO satellites do not stay in a fixed position relative to the Earth's surface. Okay, so they are visible for to the Earth station only during a period of time. So normally it is going to be 15 to 20 minutes of the time pass whenever it is passing the Earth station. So that is going to be the thing. Not somebody is asking, ma'am, Leo, the range is not less than 1000. So yeah, some cases they will be launching about 1500 or up to 1500. That is the maximum range. Okay, so it is going to be the maximum visible time is 15 to 20 minutes whenever it is coming above the ground station. So within that time, you have to capture all your signals. Okay, and this LEO orbit can also be used to cover a polar region at which some places where geos are not reachable, where geo cannot accomplish. That is where the geo signals received from geostationary orbits are not reachable. At that point, you can go for this LEO orbits. Okay, so this is how this is the height and the other parameters that we need to consider in order to place the satellite in the LEO orbit. Okay, so what are the advantages here? So this LEO satellites is very closer proximity to Earth compared to the GEO, and it gives the better signal strength because it is very closer to the Earth's surface, and less time delay is there because quickly we will be receiving the signals, and it makes a better option for point-to-point communication. That is the direct point-to-point communication. So these LEO satellites are give a small area coverage. That is it requires lesser bandwidth for transmitting the signal, okay, which are placed in the LEO orbits. Okay, and also it has some other disadvantages. That is why we go for the other types of satellite orbits. That is, what are the disadvantages here? A network of LEO satellites is needed, which could be costly because in order to have the full coverage of the Earth, okay, what happens? We need to have a network of LEO satellites. You see this picture here? Okay, a network of satellite is required in the same orbit, okay, which will be orbiting with the same frequency in order to have a continuous coverage and the full coverage for the entire Earth's curvature. So because of this, what happens? In order to establish a network of LEO satellites, it is quite expensive for a single application itself. Okay, so these LEO satellites have to compensate the other Doppler shifts that is caused due to the relative motion of the Earth. Okay, because it revolves with respect to the Earth, what happens? That affects, that is being affected by the Doppler shifts, the relative motion. Okay, because the Earth is also rotating, the satellite is also rotating. What happens? And also it is very closer at proximity, closer height. Is it not? So that is affected by the Doppler shifts. Okay, so because of that, all these factors need to be considered while designing the LEO satellites. So because of this Doppler shifts, what happens? Much of the signal might be lost. Even though good signal strength is there, because of this Doppler shifts, the signals might be lost, which are being received from the satellite. So, and also we have the atmospheric drag effects affects the what is that LEO satellites due to that is gradual orbital deterioration, which means that some climatic conditions that is occurring in the atmosphere, the lower atmosphere. So as these are at the lower height, the climatic conditions, that is the lower pressure conditions, is it not? What is that? Because of the Earth's warming up, some kind of what is that? Low pressure will be created across the ocean, is it not? So that atmospheric conditions also will be affecting the satellites which are placed in the LEO orbit. Okay, low Earth orbits. So all these factors need to be considered. So with these disadvantages, we are going for the other orbits. Okay, so this is about low Earth orbit satellites. So next we'll move on to the medium Earth orbits. So these distances are all approximately calculated. Exactly we will not know, but only at the point of launching time, they will go for the exact location or the height, the distance at which the particular satellite is to be launched. So next one is the medium Earth orbit satellites. So the approximate height, it would be 5,000 to 12,000 kilometers above the Earth's surface. Okay, so it could be elliptical or it could be circular. So these are nothing but the medium Earth orbit satellites. Okay, so this is another pictorial representation of this medium Earth orbit satellites. Here also we need to have a constellation or a network of satellites in order to have a good coverage, but at a farther distance. So as it is at a farther distance, less number of network of satellites are required. For example, if we require some what is the 10 to 15 satellites which are to be placed in the low Earth orbits for the full coverage of a network, we can go for some 4 to 5 satellites that will be required. I'm just telling a rough calculation. You should do it when we go for the Earth's coverage. Okay. So this is about the medium Earth orbits. So this is how the range of coverage of signals which are for the satellites that are placed in the medium Earth orbits. Okay, so this is another pictorial representation. So these satellites which are placed in the same orbit, that will be orbiting at the same speed. Okay, and it will be having a good coverage. So and also there will be inter-satellite links will be there, which will be giving a good coverage. So the signals from here that will be captured by this satellite, and that will be sharing with this satellite, and it can communicate with the same signal to the people who are at the other location of the Earth's surface. Okay, this is how the good and efficient communication is established with the help of the satellites launched in the medium Earth orbits. Okay, so this is another pictorial representation, and this is the one, you see. So this is one medium Earth orbit constellation. This is nothing but your geosynchronous, the other level. Okay, so the one which is very closer, that is not represented here. The one which is very closer to the Earth's the orbit, at the very closer height to the Earth's orbit will be your LEO, and a little bit farther from the Earth's surface will be your MEO. So this is how many number of satellites will be placed in its orbit, and continuously it will keep on rotating with respect to the Earth's rotation. And then what happens? It gives signals to the Earth's station. So only geosynchronous will be rotating with respect to the same speed as the Earth, whereas other satellites which are placed in other orbits will be going on with their speed, with their design specification. Okay, so this is one such constellation that is for the medium Earth orbit, and this is for the geosynchronous. Somebody is asking doubt. Yes. If these many satellites will be there, will there be any damage? Yes, accordingly, that is what I told. That is a certain, what is that, universal agency will be there, from whom you have to get permission, prior permission, when you go for placing the satellites. So they will be placing the satellites, and they will be determining and designing the speed of the satellites such that it does not collide with any other. Is it clear? So they will do all the calculations. If the satellite is orbiting in this position, what would be the speed? What is the expected time of arrival for the satellite in this position? So all these things they will be calculating, and they will be placing it. Is it clear? So uniformly there will be an agency from whom we need to get permission, and then launch the satellites. Okay, with that speed only they have to launch. So all these design specifications you need to consider, and also they make sure that it does not collide with each other. Is it clear? Anirudh also has answered. Is Anirudh clear? Anirudh, is it clear to you? Probably you can send these kind of questions to everyone, so that everyone can understand. Okay. Okay, thank you. Okay, we'll move ahead to the next one. Okay, next. Okay, so what are the features of this MEO? So MEO, it could be from 12,000, 25,000, or it could be from 8,000 kilometer to 18,000 kilometer above the Earth's surface. So these MEO satellites are something similar to LEO satellites in a sense, functionality wise. Only the distance and the range of coverage it is going to be different. Okay, So these MEO satellites are visible for a much longer periods of time compared to their LEOs. Okay, usually it will be between 2 to 8 hours. So within that time you should be able to capture the signals. Okay, so it could be quite longer duration compared to your what is that, LEOs. Okay, so these MEO satellites have longer coverage area than the LEO satellites, so as it is little bit farther away from the Earth's surface. Okay, so that these are the features of medium Earth orbit satellites. And these medium Earth orbit satellites also have some disadvantages and advantages. Now let us see what are they. So the advantages of MEO satellites are, so this MEO satellites longer duration of visibility and wider footprint means that fewer satellites are needed in a MEO network than a LEO network. As I told you already, only fewer satellites are required compared to your LEO in order to have a full coverage of network. So because of that, what happens, the installation wise, the cost, the design wise, everything is much reduced compared to your LEOs. Okay, so it also has some disadvantages. What are they? This MEO's satellite distance gives a longer time delay. So there is a delay. So accordingly, we need to boost up the signal. And also because of the delay, what happens? The signal reception will be not prompt, not exact and precise. And also the weaker signals than the LEO satellite. That is, and also it is not as bad as your GEO satellites. Okay, so because of this delay and other weaker signals, we go for the GEO satellites. Okay, so these are the disadvantages and advantages of the medium Earth orbits. That is the satellites placed in medium Earth orbits. So now let us move on to the next one, that is called to be the geosynchronous Earth orbit or geostationary Earth orbits. So it is across the equator region. So what is the angle of inclination of the geostationary or geosynchronous Earth orbit?
Should I say that degrees or else
Degree.
should I degrees?
Yeah, what is the orbital plane?
Ma'am, if it is from north to south means it will be 90 degrees, ma'am, over 90 degrees.
Okay.
Or
I'm
else if
talking
it
about
is,
geostationary.
yes,
Geostationary
ma'am.
means I told you it is across the equator. Are you able to
Yes,
see
ma'am.
the screen? Okay, across the
Yes, ma'am.
equator. So we need not talk about 90 degree. 90
So
degree means it's about,
if it is with respect to the Earth station, then angle of inclination will be 0 degrees.
yes, very good, man. That is that point. Okay, thank you,
Okay,
Kaushik. So it
okay,
is
ma'am.
going to be 0 degree. So when it
0
is
degree.
placed in the geostationary orbit, the angle of inclination of that orbital plane, it is going to be 0. This is about the geostationary Earth orbit. So it is exactly about the Earth's equator. You see, so this is another representation here. Okay, so I told you there is quite a little, little difference between geosynchronous and geostationary. So both geosynchronous and geostationary will be rotating with respect to the speed of the Earth, the same as the speed of the Earth. But the little difference is this geosynchronous will have angle of inclination, but this geostationary, it is going to be 0. That is the point to be noted here. Is it clear? So this is the Earth's Earth, and this is the center axis. Okay. So we talk with respect to the center axis, and this is going to be the, what is that, geostationary orbit, which will be having the angle of inclination to be 0. It is exactly above the Earth's equator. Okay, and this is also going to be geosynchronous, but it will have the angle of inclination. But the speed of rotation of this of the satellites placed in both these orbits will be same as the Earth's rotation. Okay, so that is the important point you have to note here, both geostationary and geosynchronous. Okay, the important point here it is geosynchronous will have angle of inclination, whereas this geostationary, the angle of inclination will be 0. So I will ask this question in the next class on Friday. Okay, have this in mind. Okay. So this is another representation here, you see, with the Earth's tilted angle of inclination. Okay, so this is the axis and this is the equator. So it will be placed above, exactly above the equator. So this is the maximum distance at which this geostationary orbits are designed. Okay, 35,786 kilometer above the Earth's surface. So this is going to be the geo orbit. Okay. So this is another representation which shows you the difference. You see, so this is the orbital plane. So this is the front view. Okay, edge view, or you can tell it as edge view of the orbital planes of the geostationary and geosynchronous orbits. You see, it's the red color line. Okay, so this is the edge view of the orbital plane, that is going to be the geostationary. It is exactly above the Earth's equator, and this geosynchronous, it is going to be quite tilted. It could be here, anywhere here within this range. Okay, and it is going to have the angle of inclination. Okay, so this angle of inclination, again I repeat, the angle of inclination is for the orbital plane, whereas the angle of elevation is for the satellite. Is it clear? So we'll move on further. Okay. So what are the features of this geo? Okay, so these satellites are placed in an orbit of height 35,863 kilometers above the Earth's surface along the equator. That is the important point here. That is going to be geostationary. So the objects placed in the geostationary orbit revolve around the Earth at the same speed as the Earth rotates. So this is the second important point. So it means that these satellites remain in the same position relative to the surface of the Earth. That is what, when we go for our television channels, your dish antennas you will be placing at our home. Is it not? So normally we'll fix the position of the dish. So many of us are having your Tata Sky and your, what is that? What is your Airtel and so many other television channels which provide dish antenna. Is it not? So they will be at a fixed position. We are not going to change the position with respect to the rotation of the Earth. Is it clear? So it will be at a fixed position. So this all the television channels which gives a continuous coverage of signals for television telecasting and other continuous monitoring for health and on the defense applications. All the satellites will be placed in the geostationary orbit, which will be fixed in position. Okay, so normally we place the dish antenna at a fixed position. Is it clear? So the first important point here, it is going to be, it is placed above the Earth's equator at a distance of 35,863 kilometers approximately. Okay, and this satellites orbit revolve around the Earth with the same speed as the Earth's rotation. And also it remains in the same position, and the same phase of the satellite will be focused to the same range of coverage of the Earth's surface. So these three important points you should know down in geostationary Earth orbit. So at the geostationary orbit, what happens? The satellite covers the 42.2% of the Earth's surface, and theoretically speaking, this three geostationary satellite provides the 100% coverage of the whole Earth. Okay, so for example, we will be able to view the the TV channels which are launched here. You see, your some Travel XP or your Star movies, this, that, other movies which are the other channels. We will be able to see how they are launching your BBC, your CNN, which are being launched in their place, telecast in their place. How we are able to see, because of the continuous signals that is being received by the satellites which are being placed in the geostationary Earth orbits. Is it clear? So this is how the geostationary Earth orbits the satellites are placed in this geo orbits. Okay, so this geo orbits are useful for continuous communication applications and the ground-based antenna, which must be directed toward the satellite, so it can operate effectively without the need of expensive equipment that is needed to track the satellite's motion. So especially for the applications such as direct TV distributions and where we need not go for extra equipment that is required for the ground communications. Okay, and the onboard complexity of lifting a satellite into a relatively high and placing it in that satellite orbit, geostationary orbit. All these things, factors we need to consider. So it helps all in all this way. But there is a quite complexity of launching this satellites and placing it in that particular orbit. Okay, so that is going to be quite complex. So it also it requires a lot of manpower for designing this satellites to be placed in the geo orbit. Okay, and also this geosynchronous geostationary orbits have quite few number of advantages as well as disadvantages. So this geosatellites, as it is very far away from here, then also it is placed across the above the equator, it provides a larger coverage. Okay, and also these geosatellites have a 24-hour view of for a particular area. Therefore, it is used for the satellite broadcast and other multi-point applications. So, and also there will be inter-satellite links. So, it gives a continuous communication without any disruption here. And some of the disadvantages here it is that, so geosatellites distance also comparatively have both comparatively weaker signals. So, it is very, very far away from that place, is it, or from the Earth's surface. So what happens, there will be the signal will get weakened, and also there will be some time delay, wherein we go for compared to the point-to-point communication, the signals that are received from the geostationary satellites will be weak. So what we need to do, we need to have many number of repeaters or transponders. Is it clear? In order to capture this signal, boost it up and transmit to the ground station. Okay, so we need to have more number of repeaters. They call it as repeaters or transponders. So as it is very far away from the Earth's surface, and also as geosatellites are centered above the equator, so the difficulty of broadcasting is there for the people who are there in the polar regions. So is it clear? So when we go as they are exactly above the equator, the signals get weakened when it is closer to the polar regions. That is why specifically for polar region coverage, we go for that is that Volnia orbits and other elliptical orbits, which will be giving a good coverage in the polar regions. Is it clear? So these are some of the disadvantages of the geosatellites. Therefore, as we had some of the disadvantages here, we go for the other satellite orbits as well. Okay, so this is another representation of how this geos are giving a good coverage for the entire Earth's surface. Okay. Okay, so I told you about this Molnia orbit satellites that is used, so for which will be giving a good coverage for the polar regions. So it is used by Russia for many number of, there is many decades. So this Molnia is going to be a perfect elliptical orbit. So the satellite remains nearly in a fixed position relative to the Earth for 8 hours. Okay, so a series of 3 Volnia satellites can act like a geosatellites. 3 satellites which are placed in the Volnia orbit can act like a geosatellite, which will be giving a continuous coverage. So it is very useful near polar regions. Okay, and this is another representation, that is the pictorial representation of image which shows the Volnia orbit. So satellite is launched here and it will be orbiting in the polar region, across the polar region in an elliptical orbit. Okay. And I talked about this, the last type of satellite orbit, that is going to be high altitude platforms. So one of the newest idea of satellite communications, when we wanted to have continuous communications, that is a plane around 20 kilometers above the Earth's surface, used as a satellite. Okay, so this what is that? High altitude platforms will provide a small, very small coverage area, but would have comparatively to other orbits, it will provide a good coverage. So why the satellites are used? So we wanted to go for discovery of what is that, some surveying of land, and in order to have analysis of mineral deposition on the Earth's surface where the human is not able to reach. In such places, this high altitude platform satellites are used. So these are very cheaper to put into the position, but it would require a lot of them to have a very good network. When we wanted to have a good coverage of a larger area, obviously we wanted to have more number of high altitude platform satellites. So you see, so the small satellites that will be launched here, that will be having, see, you see this forest fire, they'll be keep on monitoring, and when we go for the sea, oceans. So in oceans, we will not have any other signal. Is it clear? So in such places, these satellites will be used for getting communicated with the people there in the ship. And also you're seeing some industrial places and also the places where we are not able to reach. That is the, what is that? Fields or the forest. Okay, when they go for forest survey and what are the climatic conditions, that is the meteorological department. They wanted to go for continuous monitoring of signals. This high altitude platform satellites. So they will be getting communicated with other satellites. You see, so these are the satellites which are placed in the LEO orbit. So you see the satellites that are placed in the LEO orbits, whereas this one, and this one are the high altitude platform satellites. So they will be giving a closer view of the survey places where we wanted to communicate, and they will be communicating to the satellites placed here, and there will be inter-satellite link communication, and that is how they communicate the entire Earth's coverage. Okay. So this is another represented. So you see, so this what is that? HAP, that is the high altitude platform relay, that is getting communicated with the LEO, GEO, and other platforms here. They get communicated. Okay. You see, so it is a sequence of high altitude platforms that are placed in the mountain regions. So how these mountain regions where we are not able to reach there, how they are getting surveying, doing a kind of research on exploration purposes, they use this high altitude platform. So this is a sequence of high altitude platform devices that will be used for making a survey, and this will again get communicated to the satellite that are placed in the other orbits, and will get continuous communication. Okay. So these are used for meteorological purposes, survey purposes, and for exploring new things on the Earth's surface and from the forest where the normal people are not able to reach. Okay. And these satellite orbits you see, so these are the LEO satellites and these are the GEO satellites, and this is the Earth station, how it is getting communicated. So this is above the Earth's atmosphere, this white structure, the what we see is nothing but your Earth's atmosphere. The blue ones are the sea. So the ground station will be here and they will be getting communicated, and also there will be inter-satellite link between LEOs and GEOs and all other satellites. Okay, suppose we wanted a signal from a particular satellite, we'll get prior permission and they will get license for that, and they will be able to communicate. Okay. And you see, this is another picture of how the physical actual, so this, it was taken by an aircraft at the night. Okay, so this is the actual real picture of satellite. So here sun is there and here it is night. So this side it is day for them and here it is night for them. Okay, what is this continent? What is this continent? What is this location? Can anyone tell? This, what is this continent and this continent? That is this exact location is. Can anyone tell? Yes, it is Europe and this is Africa and this is Asia. Okay. No, so I just wanted to show another 1 minute video how the satellites are getting orbit in the orbital plane. So continuously it keeps orbiting. You see? So the one which are very closer to the Earth will be low Earth orbits, and one which is very far away will be the medium, and the later one is going to be your GEOs. So it will keep on continuously orbiting in its orbital plane. Same things. Yes. So hereafter we are going to log. Okay, you see a continuous rotation of the satellite in its orbit. Okay. I wanted to show another video also. Are you able to hear? was taken by one company there. SES. So they have the satellites in GEO and MEO for their
SES,
applications.
together with O3b Networks, is the only operator to have satellites in 2 orbits, GEO and MEO. This unique complementary offering expands the breadth and depth of our products, opening up new market opportunities. The geostationary orbit, known as GEO, is approximately 36,000 kilometers above the equator.
Kind of thing.
At this distance, GEO satellites seem to be fixed in the sky, while in fact they are turning at high speed with the Earth. This allows, for example, the TV dish on your roof to be fixed, ensuring TV reception at all times. A single GEO satellite can cover 1/3 of the Earth's surface, broadcasting content and delivering connectivity simultaneously to millions of people. The medium Earth orbit, known as MEO, is 8,000 kilometers above the Earth. Thanks to the reduced distance between these satellites and the Earth, the signals need less time to be transmitted, making it ideal for applications where low latency is key. Recent technological advances have resulted in a significant increase in capacity in both GEO and MEO satellites by reusing multiple spot beams, which in turn reduces the cost per bandwidth. With its combined offering, SES is ensuring that millions of people can enjoy high-quality TV programs from GEO satellites, while the MEO's high-powered beams enable passengers to Skype, surf the web, and play games online.
So this is because of all these features only we are able to have a continuous internet connection.
An excellent example is the Quantum of the Seas cruise ship, which enjoys more bandwidth than all the other cruise ships in the world combined. For the first time, passengers on board can enjoy the highest level of connected cruise travel. With our innovative technologies, a completely new travel experience has been created. SES has opened up a new horizon in connectivity.
Okay, so this is about how the satellites are being used for your continuous applications. Okay, so do you understand? So what are the topics we have learned today? Can anyone summarize? Okay, so before that I just wanted to conclude that is based on the types of services that is provided by the satellites. Previously the classification was based on the orbits in which the satellites are placed. We classified as LEO, GEO, MEO, MOLNIA and high altitude platforms. So based on the type of services that is provided here, we have fixed services satellites, that is FSS, which is used for point-to-point communication. Normally it will be used in LEOs. Okay, whereas we go for next, the second classification is broadcast service satellites. I think but your continuous satellite television and radio communications, most of the satellites will be placed in GEOs. And they are also called as direct broadcast services. And also in other range of communications, that is the services provided by satellites are your mobile satellite services satellites, that is MSS. So which will be giving a satellite phones. Have you heard of satellite phones? Okay, so it will be able to communicate. So we don't require any landline connection or any physical connection or mobile connection. So direct satellite connection will be there through satellites. So we have satellite phones as well. So these satellite phones are in use in foreign countries. So most frequently we don't use it here. Only very few people use here in our country. Okay, there's some kind of many people who are the category of VIPs, they use satellite phones, but normally it is in practice in foreign countries. Okay, so these are the services which are provided by the satellites. So based on the types of services provided by the satellites, they are classified as fixed service satellites, then broadcast service satellites and mobile service satellites. So that is about the satellite services. So this is another important point that we will see in the tomorrow's class. So can anyone summarize what are the topics we have discussed today?
Types of satellite orbits, ma'am.
Yes.
Low Earth satellite.
Very good.
Medium Earth orbit.
Yes.
Geostationary orbit.
Yes. Yes.
Molniya orbit and HAPS.
Yes. High altitude platforms.
And service types.
Okay. Okay, ma. Thank you so much. I'm so eager. Yes, very good. Thank you, ma.